All right, so this one was about a tenant entering into a lease that has the option to make a down payment to lower the monthly rent and assume a 6% interest rate, which option has the best present value. So you can almost think about this as like if you were buying a house, right? And you could get like, what would be the best way to do it? You could pay nothing down and so much a month, or you could put something down and the question is how much. And if you're, if you were to put that much down and your monthly payments were to be these numbers, what would be the best option? Now, obviously, if you don't have the cash for a large down payment, then option A is going to look the best. But if you do have that flexibility, there still may be one option that's better than another, and it depends on the the magnitude of the down payment and the magnitude of the monthly payment. So since the interest rate is fixed and the duration of the lease is fixed, we can basically just take those future cash flows and turn them into present values and add them together. So let's take the first case is the simplest because there's nothing down, but let's take the time to actually like think about what a cash flow diagram would look like for that. We have nothing down. So in year 0, we're gonna have nothing. And then for 17 years, we're going to have a fixed monthly payment. So if I really wanted to do this accurately, I'd have to do 12 times 17, which is 204, I think. So I'd have to do 204 monthly payments, but I don't want to do 204 compounding periods. So I'm going to make the simplifying assumption that the 12,500 monthly payment is an annual payment of 12 times that much, which isn't quite true. So this will introduce a bit of error into our problem, but it's going to be close enough for us to make the comparison between these 4 options. So we would do 17. Well, I suppose I should make, well, how do we want to think about this? We could make them negative and draw them below the line like that because they're payments, but I'm going to just let everything be a positive value since everything is outflow here. You're buying something. So we would do 17 of these and ... And here's the 17th one in year 17. And sometimes you can draw this like that. You'll see that like straight across in some diagrams. Okay, so then how do we articulate that from a calculation perspective? Well, the present value is going to be that annual cost. So 12 times 12,500. And that's annualized. So now we want to multiply that by a cash flow factor, which is P given A, which depends on the duration and the interest rate. The interest rate is 6%, and the duration is 17 compounding periods. Again, I'm making that assumption that it's 17 and not 204. So then the question is, okay, well, what is that number? What is P given A, the present value of some annualized cash flow at 6% over 17 years? And there's 2 ways to answer that question. The first way, the fastest way, and the most common way that you'll probably use during the PE exam is to use the economic factor tables. And these are organized by interest rate. And the mechanical engineering reference manual in the old days with the open book had like every interest rate incremented by 1%. But here they just kind of give you a select group, right? They give you 1, 1.5, 2, but then they jump to 6. So if it's like a 3 or 4% interest rate, you can't use the tables. I didn't want to torture you and give you like a lot of example problems that used these intermediate numbers, but I did put a couple in there because I want you to be able to deal with it. One option is to use these tables anyway and interpolate. Another option is to calculate it exactly. And the way to do that is using the economic factor conversions. So for P given A, we use this guy, and that's going to be a function of the interest rate I and the number of periods N. So let's take a shot at that and see if we can't calculate this and get the same thing. So it's going to be 1 plus 0.06 raised to the 17 minus 1 times 0.06 times 1 plus 0.06 raised to the 17. So if anybody wants to do that in their calculator and help me and check me out here, it's dangerous to do math live. That's what we're here for. Shout it out if you get it before I do. Anybody? I got 10.48, call it.
Yeah, that's what I got.
Got that?
Yep.
All right, cool. Okay, so now let's validate that with the table. So we just did 6% in 17 years. 6%, 17 years, and we want P given A, 10.4773. Awesome. So that's our number. And then we can calculate what that turns out to be. I'll kind of jump to the written solution here. That turned out to be about $1.5 million. Now, well, they're all close to $1.5 million, so 1.57. So we don't have to go through all three of them, but let's go through the next one just to sort of distinguish how that's different now that we have a present value on the cash flow diagram. So now it's going to be $10,000 a month instead. So that part of the calculation is going to be very similar, but now we have this $250K down. So how do we deal with that? Well, that cash flow diagram is going to have a big $250K straight away in year 0. And then for 17 years, we have these little payments of 10,000 all the way out to year 17. So the calculation for the PV, this was PV1, PV2 is going to be 250 plus 10,000 times 12 for the year times P given A, 6%, 17, which is the same number. And that's the same structure that we'll use to put together choices C and D. And this is a little awkward. I actually mentioned this in the solution video, the fact that I said which one has the best present value. I really should be explicit there and say which one has the lowest present value, because it's the best from the perspective of the buyer. But that's pretty much the idea. So I think what you'll find with all these econ problems is just draw the cash flow diagram, and there's a couple little tips and tricks and techniques, and I write example problems that take you through each one of those one at a time, and in kind of stacking the ideas together and into a few more complex problems toward the end. And by the time you get through that, you're going to have flashbacks to college and you'll pretty much remember how to do this stuff.
Thank you.
Yeah, you're welcome. All right, guys, it was a quick half hour. Anything else that anyone's dealing with that they want to chat about? Going once, going twice? All right, guys, I'll leave you to it. Have a productive week and talk to you soon.